Today, we're going to dive into a fascinating exploration of one of humanity's most complex creations, the human brain, and how it's linked to the rapidly evolving field of artificial intelligence. While the brain is an extraordinary organ that has evolved over millions of years, artificial intelligence is a technology that aims to mimic the very processes that make us human. What happens when these two powerful systems, the biological and the digital, begin to intersect? Join me as we uncover the deep connection between the brain and an eye and explore how this relationship is shaping the future of both science and society. Artificial intelligence, or AI, refers to the simulation of human intelligence processes by machines. In other words, it's the attempt to create machines that can think, learn, and make decisions like humans. But how exactly does an eye mimic the human brain? At its core, AI operates on algorithms and models that aim to replicate the way our brain processes information. The earliest AI systems were inspired by the idea that machines could think by emulating human cognitive functions. However, AI's journey has been far more complex than simply copying our brain structure. AI systems have evolved over decades, from early rule-based systems to the more sophisticated deep learning models we see today. Now, let's take a deeper dive into how AI mirrors the workings of the human brain. Both the brain and AI utilize neural networks, though they are constructed in fundamentally different ways. The human brain contains approximately 86 billion neurons, each connecting to thousands of other neurons, forming an intricate network that allows us to process information and learn from our experiences. AI uses artificial neural networks, ANNs, which are designed to function in a similar way, with nodes representing artificial neurons. However, unlike the brain, AI systems learn through data input rather than through sensory experiences or biological evolution. When we teach AI to recognize patterns, it processes large amounts of data through these artificial neural networks, which learn by adjusting the connections between nodes based on the outcomes they produce. This is similar to how synapses in the human brain strengthen or weaken in response to repeated stimuli. But there's a key difference. While the human brain has evolved for millions of years to learn and adapt in complex environments, artificial intelligence systems are still in their infancy in comparison. One of the most exciting frontiers of science and technology today lies in the realm of brain-machine interfaces, or BMIs. This technology connects the human brain directly with machines, allowing us to control devices with our thoughts. BMIs have enormous potential, particularly in the medical field. For instance, people with paralysis can now use brain-controlled prosthetic limbs, regaining mobility that was once thought impossible. The technology works by detecting electrical activity in the brain and translating those signals into actions, essentially turning thoughts into commands. But the implications of BM extend far beyond medical applications. Imagine a future where individuals could communicate instantly with machines or even other humans, simply by thinking. Imagine controlling your home's lights, opening doors, or navigating virtual reality worlds all with your mind. The integration of an eye with BM could eventually allow for seamless interaction between humans and machines, enhancing cognitive functions and creating new opportunities for learning, creativity, and exploration.